So this is the augmented reality sandbox. It was built by the team from the Aristotle University of Thessaloniki, and it was funded by the Erasmus Plus project educational laboratories, Big Machine. This is custom made. We made it with various parts, and it was constructed following the instructions that were provided by the original constructors from UC Davis in the United States. It comprises of several parts. This is the start, this is the origin of the whole process. It's the Kinect sensor by Microsoft. And this sensor sends infrared rays to the box that you can see here. This is just a wooden box filled with sand, clear white sand, simple sand. And the Kinect sensor recognizes the distance. It scans the whole place, the whole box, and it recognizes the distance between the Kinect and the nearest obstacle, which is of course the sand. This information is transmitted to a computer. You can see here. This is a very, very simple computer with no difficult parts in it. It just has a very fast processor and a very good graphic card. So the computer receives the information from the Kinect, and it transforms this information into level above what we call sea level, what we call zero, what we define as zero. It designs the contours, as you can see here. So it makes an interpolation and identifies the contours and designs the contours, and then it assigns colors based on a color scale that we defined, and which resembles the color scale of a simple map. The image as it is processed is also shown in the computer's screen monitor, and if we want, we can change this monitor to a projector, a larger projector, in order to have a better angle of the object. Then this information is transmitted to this projector. It's a short throw projector. It's not the usual projector because we need to project in very small distances, to focus in small distances, and this projector projects the same image. So this whole process is done very, very quickly. So if I make any change, you can see that the whole picture is redesigned. The distance is recalculated, the contours are recalculated, the colors are reassigned, and then we have like a moving map. So we ask high school students or our students from the university to actually play with the sand and understand the concept of the map and understand the features of a map. What we have here is something that resembles a lake. So we define a level we call zero, and below that level, whatever is below that level is identified as sea. Whatever is above that level is the plain, the mountains, and the top of the mountains. Another interesting feature that is included in this sandbox is the rain. So if the projector identifies an object where it's not supposed to be, it recognizes it as a cloud, and as you can see here, we have rainfall. Rainfall follows the slopes. You see here the slopes of the sand, and it follows the slopes as normal rain would. And you can see here water moving. Actually, this water moving is a very complex issue because the computer solves Navier-Stokes equations in order to identify the movement of water. And so in this way, we can have a very good image of water flowing, of surface water flow, or floods. We can simulate floods, and we can identify this and present them to our students, and they can understand perfectly hydrologic phenomena. So this is something, the whole concept is something between something you can play with. We have children coming here and playing with the sand and seeing the movements, the changes that occur due to this, to their actions. And at the same time, we can see and we can teach our students about the surface water flow, the concepts of hydrology, and they can understand some flood effects. They can, you can do things like that. This is a small dam. As you can see, I separated the water, and the water moved again into the new lowest points. So students can understand the concept of hydraulic works as well.